I should be making a video, live video, another DraftPhysics.com, debatephysics.com video presentation. This time augmented by what they call artificial intelligence. Yeah, I don't know. It's too bad that term is being used because it really isn't artificial intelligence. It's, artificial rhetoric. It's synthetic production of personality. It's a lot of things, but I don't know if it's intelligence. But anyway, we're stuck with that term, so I guess the world isn't going to, change. It's what it thinks something is because I say so, obviously. It takes an awful lot of time for the world to catch up to reality, and this is one of the realities that it'll probably take a while for it to catch up to. But it really isn't intelligent. So anyway, I've been playing with what they call Notebook LM. I don't know. It's kind of a funny name, frankly. Don't know what it means. But anyway, it really does create some interesting presentation material. Both videos and graphics and slides and all kinds of different ways you can present the data. And the arguments even, and it rephrases things. There's about 400 ways you could say this cookie is tasty or something, so it comes up with multiple ways of saying the same thing, and it's quite capable of fooling a superficial inspection in terms of it sounds like people, talks like people, but it ain't people. And it ain't thinking either, but it looks like thinking, okay, and it sounds like thinking. And so anyway, it really is, I'm surprised, frankly, at how good a job it does, and it's fast and interesting and all that kind of stuff, and it's an amazing tool, and blah, 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 blah. I don't know exactly how they're going to turn it into money and all those kind of things, but yeah, it's pretty amazing. All right, so this is some 12 slides or something it put together regarding my physics theory and my competing description of the history and what the reasonable physics would indicate. And this is an interesting graphic. It's talking about the unraveling of the old notions and the bad notions of modern physics, I guess you could say. And so it isn't too bad. It's a little bit like, they could do more unraveling and less of whatever this other thing is. It's not like it's almost like they're making a rug at the same time they're unraveling a rug, so it doesn't really make much sense, but it's a nice graphic anyway. Blah, 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 blah. For free. Okay, so anyway, so that's how it starts. Okay. Let's see, and then it moves on to a simple question physics can't answer. So this is taking the statement I had on my website for quite a while. If I throw 1 unit of mass moving 1,000 miles per hour one side of a spaceship and simultaneously 1,000 units of mass going 1 mile an hour out the other side, does the spaceship turn? So they drew this kind of funny, with a spaceship that has, 2 back ends essentially. It's just quite bizarre. Obviously this wouldn't turn, but this device wouldn't move, and clearly you'd have 1,000 times more energy coming out one side than the other side by the kinetic energy theory, even though it's the same energy to produce both of those effects. I would argue they will be fueled by the same fuel, and clearly they can't produce, one of them can't produce 1,000 times more work. You have to basically choose one of these theories. Okay, so both can't be true. One of them is a phantom. There's the simple argument, and there's just kind of no way to get around that simple argument. Now, why can't I click on this? I don't know. Is something going to freeze or something? Come on. Now I want to click on that. Yes, so we can read the rest of that. So it says kinetic energy 1/2 mv squared. Energy one way 500,000 units. Energy the other way 500 units. So obviously 1,000 times more energy is ejected one way, and the ship must turn violently. Obviously if these two engines were not through the center of mass, it would have to spin violently. It would do something violently because by the kinetic energy, if kinetic energy is real, it's real energy. But the fact is it's the same momentum coming out of both sides, so therefore nothing happens because it is the same momentum, and momentum is the only thing that moves anything. And so, it's a pretty clear piece of evidence. I really shouldn't have to make these arguments for decades. Decent, reasonable people should say, yes, this is a pretty interesting dilemma. This is a paradox. You can't have it both ways. Both things can't be real. Either momentum is energy or kinetic energy is energy, but one of them is and one of them is not. But you can't conserve both, and both can't rationally. You can't rationally answer these questions believing in both. All right, so I thought that was a pretty good slide. Making concessions for the less than brilliant drawing, but it's a very precise and interesting drawing nonetheless. All right, this was a nice, frankly, it's a nice. They pulled up an image of Leibniz and Newton. Obviously this thing does. It's you're specifically feeding it one narrow sources, your sources, but it clearly is using a whole bunch of other sources. I mean, it's clearly got these images somewhere, so it obviously is able to go source material to produce what it's going to produce as an augmentation argument, I guess you could say. So, but anyway, all right, so let's move this over a little bit just for the hell of it. All right, so this is the key moment, as I would argue, is this whole thing with Leibniz. I mean, it really did start with Huygens, okay, and he started this mess. Leibniz, who plagiarized everybody, picked up on Huygens' statement about the mv squared, and then he ran with it hard. Clearly it's momentum. So here the quote from Newton, if any force generates a motion, a double force will generate double the motion. Clearly no indication that, you're going to get, twice the force is going to be 4 times the motion. No indication, anything like that. Whether that force is impressed all together at once or gradually and successively. So it doesn't matter whether it's a net force over time or an impulse. It doesn't really matter. It's always going to be whatever the force is, that's going to be the momentum transfer, because the force is essentially momentum. You might as well just say force equals mv, because it will give something a direct proportional amount of momentum. Twice the force, twice the momentum change. Clearly, the force is momentum. Clearly. All right, so pretty good. I like that slide. All right. So this one, we'll read it. An axiom without evidence. Okay, so now we're back to the Leibniz's statement. Now this is drawn kind of funny again. You just say, so yeah, it just shows the a little bit of flaws in the AI's understanding, because it's not understanding, right? It doesn't have any understanding. And so why did it make these lines not straight down? It's just it's so obviously a flaw in the drawing that that the lines aren't straight up and down, because obviously the mass is not going to fall at that funny angle. All right, but the simple argument is made, okay, that a 4 mass dropping 1 unit of distance is in fact the same momentum as a 1 mass dropping 4 units of distance. It's a different momentum because the 4 units of distance only get you 2 units of velocity. You're only in the gravity 2 units of time. Twice the velocity with a 1 mass is not the same energy as a 4 mass going 1 unit of velocity. So, again, you have to either invest in one or the other theory. You have to either understand that momentum is what makes things move in the universe, and that's what's transferred, or you understand that it's mv squared, but you can't believe in both. All right, so gravity is a time-dependent force. I don't know what other way to say that. Some physicists use the word time-dependent to mean all kinds of weird stuff. I'm only using it for its literal statement that somehow the force comes in units of time. It is in units. And it applies 9.8 meters per second of velocity every 1 second of exposure. That's the real equation. The real equation isn't 9.8 meters per second squared. It's 9.8 meters per second of added velocity per 1 second. All right, falling 4 times the distance only takes 2 times the time. That's a critical point. And your velocity is obviously only twice. So even though you want 4 times the distance, you only have twice the velocity. Therefore, it only collects twice the force from gravity, not 4x the force. So this statement by Leibniz that these two things were equal makes no sense, because two different momentums can't produce the same effect in the world. And so it has to be wrong for that reason. It's just obvious that it's not the same amount of mv. All right. I guess I'd better off just clicking these things, right? Yes, Gary. Okay, that's what I'll do. Yeah, I'll figure out how to use a presentation software. See, the software is smarter than I am in some respects. I mean, it's able to do all this stuff, And in many respects, I am not. All right, Exhibit A, the law of the lever. So it threw in levers, but again, look what it did to levers. Put all these weird gears on them. It's a nice drawing. It's interesting. It makes it, maybe it makes it more interesting. I don't know. But it's not really accurate, because you're saying levers aren't pulleys, and it's kind of turning levers and pulleys into the same thing. I don't know. So, yeah, it's probably not too good to have to illustrate the correct physics with incorrect devices, devices that don't exist. All right, so 1 mass and 4 velocity and a 4 mass and 1 velocity momentum is conserved, so that's what the balance proves, is that the two things are the same. It will oscillate, which means the energy is moving from side to side without losses, significant losses. And therefore, doing these two actions has to be the same action. All right, the balance proves a 1 mass going 4v equals a 4 mass going 1v. Kinetic energy theory claims a 1 mass has 4 times the energy. The lever doesn't balance uneven energy. So it's just a clear example that levers are effectively the proof, and the fact is they just won't do these experiments. So they'll just claim that levers don't conserve momentum and that they conserve kinetic energy, but they won't prove it. And just like they'll say the same thing about a spring, and they won't really prove it either. Okay, so let's see if there's anybody around. Just for the hell of it. Let's see. It surprises me as well. AI provides pretty interesting stuff. Yeah, but it's not really intelligent. Okay. It's just like energy, it's like you can just say, right, pointing an arrow doesn't give the arrow more energy. And you can make the argument that something going fast doesn't have necessarily more energy. It's just better at breaking systems that are dependent on speed. And so it's the same trick with this AI. The AI isn't manipulating intelligence like understanding. It's manipulating intelligence like just raw information. And it's just putting, autocomplete, but it's one hell of an autocomplete. All right, it's definitely a very interesting paradox that science is in. The fact that nobody will concede that little simple argument, that these are worthy issues to be resolved, right? I mean, we all should know for absolutely sure why an 8-pound bowling ball going twice the speed will not knock down 4 times the pins. We all should know why. Well, twice the pins, as the 16-pound ball going 8. Right? The 8-pound ball going 16 doesn't knock down twice as many pins. We all should know that as a fact. And we all should know it as a fact that, Well, it's because it doesn't have more energy. All right. So he says, yeah, the lever, the example with the lever is easy flaw to catch by human standards. Yeah, and these are all, well, I'm just saying, how much easier can the bowling ball example be? And then the spaceship example, you got a spaceship up in space, and it's basically doing the same thing as a gun, you can argue, right? You're saying there's a Newton's third law that says equal and opposite reaction. Well, kinetic energy doesn't give a shit about the Newton's third law. So how could it really be real energy if it doesn't have to obey Newton's third law? Shouldn't obeying Newton's third law be the prerequisite for calling something real energy? Come on. The answer is of course. Of course. All right, so I think we're done with this exhibit. But yeah, interesting drawing. Like I said, it's nice graphics. It throws this together in, like whatever, 3 minutes. I don't know, maybe it took it 5 minutes. But just amazing. They put these slides together. They're all pretty coherent. They're all pretty accurate. It's really, and the fact is, it's, I can slightly modify it, and it does it in a whole different way, and it's really quite interesting, all the different versions of it you can create. All right, next slide. Exhibit B, the problem with Newton's third law. See, there I just talked about the gun and the bullet, right? For every action, there's an equal and opposite reaction. So obviously the gun recoils with 1,000 times less energy than the bullet has. 1,000 times less. Or more. Yeah. Okay. So, it's just a gigantic violation of Newton's third law. So, gun recoil momentum, bullet momentum, it works. The gun and the bullet have the same momentum, so everything's perfectly reasonable. No laws have been violated. But with kinetic energy, huge violation. Gigantic disparity. 1,000 to 1 disparity. It even used the word disparity. It's just so good. How is this an equal and opposite reaction? If I shot the bullet out of one side of my ship and allowed the gun recoil out the other, would the ship turn, right? The answer's got to be an obvious no, it can't, because I can't, there's no free sources of energy. I can't possibly do that. The same explosion went this way, and the other half of the explosion went that way. And the fact that the explosion's pushing something heavy or the explosion's pushing something light can't matter. And this is the irony, right? Because they say the lever, the one mass can't go twice the velocity because somehow lighter things have more inertia, and they can't go faster. Well, how come the bullet can go so damn fast? Right? The bullet doesn't have any inertia problem. It's shooting, speeding, going huge velocity, tiny mass, 1,000 times less mass, going gigantic velocity. No problem at all. No inertia problem at all. How come the bullet isn't doing 1.4? Why doesn't it have the 1.4 problem? No answer, right? We'll never get an answer to these questions because they are paradoxical, and it does prove the whole thing is ludicrous. It's never been proven with any good experiments. They just believe this crap by faith. These fake and phony axioms, and it should embarrass people, frankly, that this is what they've fallen for. Let's see. How come it's showing more than one slide, isn't it? Yeah, the slide isn't even on the page. What the hell is that? Come on. Yeah, that's the way it should look. All right. So how is this an equal and opposite reaction? Okay, so exactly. Good question. We'll never get the answer. All right. The question they refuse to answer. So this they could call paradox 3 or question number 3, but whatever. Obviously this is this 25 times the fuel to go 5 times as fast. So it's an accurate, they did it accurately. They drew the drawing correctly. It's, they got the fuel after the speed, but whatever. Do you really believe it takes 25 times the fuel to spin something 5 times as fast? Question mark. Anybody who's done any mechanical work knows electric motors don't work that way. You want to go twice as fast, you apply twice the wattage, not 4 times the wattage. There you go. These are, that's actually quotes from what I wrote or said, but anyway. Show me one experiment proving this extraordinary claim. So they'll never show us these experiments because these experiments can't be faked. It's really hard to fake 25 times, right? That's hard to do. 2 to 1, 2 to 4, that's an easy fake to make. But 1 to 25, that's a really hard thing to fake. All right, this wasn't much. Okay, this is a little bit corny, but anyway, the wall of silence. So it has some of the Wikipedia lies, but you can't read any of this stuff. It's all too small print. And it has a nice little Professor Dave comment here about me having to pay him $5,000 to debunk my video. And then we got Coop saying, what did he say? Using cheap rhetoric and cowardly evasions. Well, that's him. No response received. Comments deleted. I don't know what that's references. But anyway, when evidence is challenged, the establishment doesn't offer proof. They offer insults, censorships, and demands for money. So they just can't really do any good physics. And it's all shenanigans. We saw that with the college professor Rousseau, who faked, frankly. It's faked in the sense that anybody looking at his experiment could see the defect in his sampling software. His sampling software it has an aberration in it. It has a function that shouldn't be there. It's doing something it shouldn't be doing. And that's just an absolute fact. And whether it means something or not, it doesn't matter because it has every appearance of meaning something. It shouldn't be there. And he doesn't care that that defect is there. And he doesn't care to show us how the defect didn't matter. Because he's not going to put those 4 rubber bands on and prove that 4 rubber bands only produce twice the velocity. He's not going to show us that because it doesn't happen. And that's how you see how they have no integrity. All right, so this slide isn't all that interesting either. But anyway, return to first principles, MV. Energy itself never changes form. So this is one of the elemental arguments that there are no forms of energy in the sense that it's just different size things moving. Heat is little stuff moving. Weight is, it's just plain and simple that you are producing a weight right now into the earth. I had my scale here. Yeah, I did. Probably tangled or something. Oh, shit, I knew I shouldn't have done that. everything's positioned to make a mess. Yeah, you have a weight this way, but you can have a weight this way. Okay, and that's your momentum. It's the same thing. Capturing this is the same thing as capturing this. So weight is momentum. Thrust is momentum. Energy is momentum. Anytime mass is moving anywhere, it's momentum. Okay, so the only quantity that's ever conserved is momentum. That's the simple argument. And there really isn't any other reasonable argument to be made. Okay, so welcome to the Push universe. So this is kind of a good drawing. It's kind of a nice, illustration, except the arrows should be all the same, right? There's no different size arrows. There's no, every bit of force is exactly like every other bit of force, just like every electron is just like every other electron. So that's a little bit, they messed that up a little. But these statements, I think, are all right. Let me see. Force is elemental, made of discrete force bits moving the speed of light. So yes, they're all the same. Except electron force is different than proton force. Matter is passive. So electrons and protons have no engine of their own. They must be siphicused into being somewhere else in the universe. They have to be pushed there. Electrons and protons are pushed by force bits, okay? And then there's 2 states of energy. The force bits are either freely flying at the speed of light or pushing a piece of matter. And if they're pushing matter, they're probably going substantially slower than the speed of light. All right, next. And slide that back over, I guess. Whoops, I can't slide over here. I have to slide it over here. or something like that. All right. So this is kind of they wrote the elegant engine of reality, 2 plus 2 plus 3 physics. So anyway, it's an accurate drawing anyway, substantially. Okay, two kinds of matter, electron, proton, two kinds of force. So that was pretty simple. They got that right. And then this absorption is clean enough. Reflection, okay, way to draw it. And then the conversion. So in a sense, this is a pretty good. They did pretty good. Now I have another slide from a different version where they messed it up a little bit. All right, so come on, let me just click on this thing. Yeah, that's what I want. All right, so it says these three interactions cause electrons to repel electrons, protons to repel protons, and electrons and protons to attract. No spooky action required. No, extra forces. You don't need any strong force to push protons into protons because frankly, the electron will do the job for you. So it fixes an awful lot of physics. All right, so it's another drawing for the purpose of describing gravity. But again, it's not, the shadow argument isn't actually my argument. I mean, obviously that's what it does produce. But it produces it not by blocking, but by just retarding. Okay, slowing things down, not annihilating them. All right, so the universe is under constant pressure from the sea of force bits, and the pressure is in all directions. So this makes it look like there's more pressure on one side than the other, so it's a little bit lopsided, but really it's not bad. When force bits push matter inside the Earth, their energy is delayed or consumed. So it's not really consumed. You can't ever consume energy. So the argument is it's delayed. And the delay means it's more dense, so there's a thicker amount of the energy because it's moving slower. So when it slows down, it thickens. This creates a pressure differential. More force pushes you in than pushes you out. So the simple truth is, because the energy is retarded, slowed down, getting through the Earth, it doesn't show up where it's supposed to show up to push you, to keep you levitated, okay, to keep you from falling. And that's the simple truth. You fall into the Earth because there's a push on the outside and there's not enough push between you and the Earth because the pushers are stuck heating the Earth. This is gravity. The consumed energy is released as heat, which is why celestial bodies have hot cores. So it's pretty simple. And it's pretty accurate and pretty descriptive and pretty good. Yeah, let's see if there's any comments. All right. Let's see. NASA should do the recoil gun experiment in space. Would be very interesting video evidence. Well, obviously they should do any of these experiments. I mean, frankly, they're never going to be able to do a lever and make it do the 1.4 thing. So, yeah, all of these experiments could be done. And, yeah, they should all be done from space because it's such a nice, clean environment where you don't have to worry about any friction. Lots of things, lots of advantages. But, frankly, they could do all of them from Earth too well. And they know they can, and they don't. And everybody has to ask the question, why? Why hasn't NASA done the Eddington experiment from space? I mean, it's a $500 experiment. I mean, I'm being realistic. It really is that. It's almost a nothing experiment. It's so little satellite time, and it demands almost nothing from the satellite in terms of its 15 minutes of satellite time, frankly. Moving the satellite, adjusting it, taking a few pictures, and then that's it. It's almost nothing to it. And there's no excuse that it hasn't been done. There's no excuse, except bad excuses. All right, anyway. So a photon is not a wave. It's a pattern. So this one, they really did make a mess out of this. So obviously, this isn't, photons aren't this kind of a pattern. They're discrete bits at a frequency. They're not arrows going this way at a frequency, so this graphic isn't too good. All right, it says a photon is not a thing but an event. Well, that part's true. It requires a sequential events to happen on a surface, and then the surface will produce electricity. It is simply a bit of force arriving at a surface with a specific frequency, the time spacing between the bits, and the polarization, the orientation of the bits. So they fly through space parallel, and that, however that parallel is arranged, that's their polarization when they hit the surface. Dot, 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 or dot, 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 or dot, dot, dot. All right, this pattern is what allows energy to be transferred effectively, like pushing a swing at the right time. There's no wave-particle duality. So obviously it is a resonant frequency, you could argue, or the simple argument is that you can't add energy to a system unless you hit something while it's moving in the direction you wish to add energy to it. If it's moving in the opposite direction, you can't add energy. You will subtract energy. You will subtract momentum. Simple argument. All right, paradox is resolved. The ballistic pendulum. So big proof. Again, 1,000 to 1 kind of thing. All the kinetic energy is lost. The faster I make the bullet, the more kinetic energy I lose in the experiment, all the way up to numbers like 99.94%. Just gigantic, insane amounts. Their argument is somehow it was lost to heat, but there's no evidence that any heat was created in that amount inside the pendulum. No evidence whatsoever that that somehow you conserved all the momentum, and yet you made thousands of joules of heat. You can't use the energy twice. You can't make momentum in the form of heat and still have your momentum. You can't conserve the momentum and make heat. Can't do both. All right, momentum is transferred to the momentum of the countless vibrating particles, the heat within the pendulum. Momentum is conserved, just redistributed. So this is wrong. The momentum goes into the linear motion. The momentum is almost all captured. You capture 99 or 95% of the momentum. You only lose 5% of the momentum to heat. So a gigantic proportion of the momentum stays as linear motion. And it's the kinetic energy where none of it is linear motion, and all of it has to be described as being heat, but there's no evidence it's there. There's no experiment demonstrating any indication that that much heat is there. They have zero evidence. Hundreds of years to produce the evidence, zero evidence. All right, rolling objects. This is one of my favorite arguments, frankly. You can just tell that, yes, you roll something with twice the velocity. It will travel 4 times the distance before it runs out of energy. But the fact is, it didn't do 4 times the work to go 4 times the distance, because most of that distance it was traveling a higher velocity. And when it's traveling a higher velocity, it's actually losing less energy to the surface because it has less contact with the surface. And that simple truth is that something with twice the velocity will only make the ground twice as hot, because it really is only putting twice the pressure on the ground, not 4 times the pressure. So twice the velocity is only twice the energy. 4 times the distance, yes, but the distance is not how you define the amount of energy, because you gain distance with velocity, because you cheat friction in this case. In the case of contact, of rolling contact, you cheat the friction with velocity. The faster you go, the less pressure you're putting on the surface per inch. Just an absolute fact. You weigh less per inch on the surface. The faster I make you go across a scale, the less you'll weigh. It's a simple truth. If I could put this into the floor and you were to roll something across it, if I roll it really slowly, it'll weigh its weight. If I roll it fast, it'll weigh less and less and less until I could make it weigh almost nothing at all. Fact. All right, and then the clay balls is basically the one about, they did it backwards. It's, lead or copper balls into clay. But the fact is this drawing here is kind of funky, with the whatever that is. But the simple point is the obvious point is that the fact is when a round object penetrates the clay, when it first hits the clay, it has a very flat surface pushing straight down. And as it goes deeper and deeper, it starts pushing more and more clay sideways. And so that's why something that's just denting the surface, when it goes twice the velocity, it's taking advantage of pushing clay sideways instead of having to push clay down. So it displaces more clay, but it didn't do more work. It just displaced more clay because it pushed, like an arrow, it pushed it sideways instead of pushing it forward. It's more work to push it forward than it is to push it sideways. Simple argument. All right, the faster ball makes a bigger dent, not due to the more energy, but because it acts like a pointier arrow. Yeah. The deeper it penetrates, the more efficiently it displaces the clay sideways instead of just down. So this explanation is good, even though the drawing is a little bit, nobody would draw that. Nobody I know would draw that. Let's say that. Yeah, I did all these, right? Just making sure. Okay, so this should be the last one, I think. Maybe. Possibly. Yeah, last one. All right, so this one doesn't say much. So, yeah, this drawing is a little bit, yeah, okay, that looks sort of like modern goop. And so this is a simple definition, just matter and force. But, you know, they don't really have the force connected to the matter properly, so it's not really saying much. But the statement, okay, the universe isn't spooky, it's a machine. How come that isn't showing up where you are? Interesting. There it is there. Well, I don't know. My fault, probably. The universe isn't spooky. It's a machine. The only thing that does work, the only thing that's real is momentum. So, pretty good. All right. So, I think I'll play one of the videos that made. So I'm pretty tired, so I can let that play and I can just go to sleep. You know, I could play it, and you know, if I have to point out something that's wrong, I'll point it out. All right, so maybe we'll close that, and we'll open a video. We'll find the videos. Okay, that's not what I'm looking for. That looks like this is the most recent video I did, so I guess we'll play that one.
Welcome to the Explainer, where we break.
Yeah, this is I did in anime form. Is that you have these choices of different ways, and so this one's anime, so it's really, it's pretty bad. But the content isn't bad, and it's really. There's these are minor downsides, but you can't change the voices they use, and so there's lots of things that it'd be really great if I could actually modify the voices, because they have some that are just inappropriate. They just don't sound right. They don't sound like somebody who'd be talking physics. And so it just seems out of character, if we can use that terminology. All right, so I should be able to find this and put it in here. And this is called the energy formula. I guess that would be what it's called. Yeah, there it is. All right, so I should be able to play this without too much problem. Let's see how the sound goes.
Welcome to the Explainer, where we break down complex topics using the source material itself. Today, we're looking at an idea that challenges something you almost certainly learned in your first physics class.
So get ready for this. We're diving into an argument that says the very definition of energy you learned in school, it's just wrong. The claim is that for centuries, physics has been using the wrong formula.
So yeah, this whole thing comes down to a centuries-old fight between two different ways to define energy. On one side, you've got momentum, just mass times velocity, mv. And on the other, you have what we all learned in school, kinetic energy. That's 1/2 mass times velocity squared, 1/2 mv squared. And the argument we're exploring today says one of these was a huge historical mistake.
All right, so here's how we're going to break this down. We'll start with the old feud, then look at this idea of the universe's basic particles. We'll see why the claim is that momentum is the real energy, rethink what a photon is, and see how matter shapes forces like gravity. Finally, we'll ask, is this science really settled? Okay, let's dive in.
Okay, first up, physics' oldest feud. This is a 300-year controversy over the true nature of energy. And this debate actually started way back in the 1700s. It was basically Team Newton versus Team Leibniz. Newton's followers were all about momentum, but Leibniz argued that the real living force...
Okay, so how's this sound? Does this sound good? Yeah, I have to ask you people. I mean, is their sound the same as my sound in terms of volume? What else do I want to say? Something else. I don't remember. Yeah, this is weird, right? I mean, these pictures of Newton and their Leibniz. This is not Leibniz, okay? I mean, this is Newton with the apple, and that's not Newton's picture. These are like George Washington or something. I mean, this is just, that's not too close. So, yeah, this really was a little bit wacky. Some of this was a little bit off. But anyway, it's, considering, and I didn't have to do any of this writing, that it basically composed this, unique version of an explainer, and it's really not badly explained.
force of an object was its mass times velocity squared.
Yeah, this argument wasn't settled overnight. For a long, long time, scientists and thinkers were going back and forth. You had these key experiments like the ones Madame du Châtelet popularized, where they dropped metal balls into clay, and what they found seemed to be a smoking gun for kinetic energy. See, if you drop a ball from 4 times the height, it makes an indent 4 times as deep.
So you can see, it's like they have her playing with clay, and then they have flames coming out of the clay. It is pretty kind of funny because it's, it's not really denting clay, and the table has a dent in it. I mean, it's just kind of funny. It wasn't clay balls hitting a table, I mean, it was, metal balls hitting clay. But anyway, and then, and put her in a lab coat and all that kind of crap when she was pretty much a slut. I think this other guy's supposed to be Joule, and so they have a little beaker, with heat coming out of it, so that might be some idea of a Joule tank or something. But it is pretty funny how it's pretty funny. That's all I have to say. It's pretty funny. Not exactly true. Not exactly the real history. But really, like I said, it made up all this crap, or stole it, or whatever, plagiarized it, but whatever. I mean, it is. You can't deny they're pretty good drawings.
Not double, but 4 times. That perfectly matches the velocity squared part of the kinetic energy formula.
I mean, she has 5 fingers and everything.
So by the time James Joule came along in the 1800s with his
See there, so this is Joule here.
work on heat, it pretty much sealed the deal. Kinetic energy became the standard. But the source material we're looking at today claims this is exactly where physics took a major wrong turn.
All right, section 2, force, the universe's particles. So if you're going to challenge a concept as huge as kinetic energy, you need to rebuild physics from the ground up, right? And that's what this alternative model does. It proposes that the universe is made of something way, way simpler than all the fields and waves we usually talk about. And it all starts with this one idea, the force bit. Think of it as the universe's most basic building block. It's this tiny, fundamental particle that is literally just momentum, and it's always moving at the speed of light. In this model, everything we call force, gravity, light, magnetism, you name it, is just a whole bunch of these force bits.
So how do these things work? Well, it's actually incredibly simple. According to this model, these force bits interact with matter in just 2 ways. 1, they can get absorbed. A force bit hits something like an electron and just sticks to it, transferring its momentum and giving it a push. Or 2, they can get reflected. A force bit hits something that's already moving.
All right, so it's not, again, it's a little bit short of the reality in the sense that when the force bit reflects, it actually does reflect one from the other side. So it's releasing energy that was previously captured. So there's a real equal and opposite event. You could actually see it will look equal and opposite. So the absorption is the one that doesn't have any equal and opposite. That's the one where, Newton is he's making an argument from an explosion sense that there's always a left side to the explosion and a right, an up and a down. But there are circumstances when a force hits something and there's only one way for it to go, and that's to keep going forward. Okay.
Bounces off, and that changes the object's momentum. That's it. It's all about this simple mechanic. Force moves matter.
Okay, section 3. Momentum is the real energy. So with this force bit idea in our back pocket, let's see how this model tries.
So it's good they threw in the bowling analogy here, right? And then they threw in collisions. So they're getting it. The skateboard thing, that ain't too useful, but whatever. And they have this weird little wavy thing happening, but whatever. Close.
To prove its case using stuff from the real world, like simple machines and collisions.
And believe it or not, the source we're looking at says the key to...
So this is this is supposed to be a lever, and it's more like some kind of, I don't even know what the hell it is. It's a tie rod from a steering column or something on a car. It's I don't even know what the fuck that is supposed to be. But anyway, they got the Batmobile here flying through space or something. I don't know. So it is a little bit, a little much. But whatever, MVS, the MVS have to match. The laws of the lever basically tells you the MVs, that's supposed to be the MVs have to match. Yes, the momentums have to match. So it didn't really say that very literally. That's a little bit, not too good. But again, it's all, I'm just surprised that it can construct all of this out of the text.
This whole debate, the proof, is a tool that's been around for over 2,000 years, the simple lever. The argument is that the law of the lever, well, it's really just telling you that the momentums, the MVs, have to match.
Okay, now check this out, because this is where it gets really weird for the stand.
This is, I don't even know if this is readable. But anyway, so they have a lever, but they've put a graphic on top of it to ruin it. So that's sort of disappointing.
Model. Look at a simple balanced lever with a 4-to-1 ratio. On one side,
so, and they don't have the 4-to-1 ratio. She's not four times the distance, so it's just kind of blah, 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 blah. It's not accurate.
you have a 1 kilogram mass moving at 4 meters per second. Its momentum, mv, is 4. On the other side, a 4 kilogram mass moving at 1 meter per second. Its momentum, also 4. See? The momentums are perfectly equal, which is why the lever balances. But now, look at the kinetic energy. The first side has 8 units of kinetic energy, but the other side only has 2. That is a massive difference.
There you go. And it's a real paradox. And again, they just keep pretending there's no paradox here because they're going to claim that somehow the balance doesn't balance. That somehow if I make one of these balances, it won't balance. And of course I did make one, and I had it on my porch, and it balances just fine. So they're saying it can't happen, but it does happen. So there's no real argument here. I mean, it's an absolute truth that the lever won't make the half mass or the 1/4 mass. Okay, it won't cripple it and prevent it from going twice as fast or 4 times as fast. It will, in fact, conserve the momentum. And that's the law of the lever. Conservation of the momentum is exactly consistent with the law of the lever. There couldn't be a law of the lever if it didn't conserve the momentum. So
how can one side have 4 times the energy?
This shouldn't be an argument among reasonable and honest people. Reasonable, honest people can't argue these facts. So I'm obviously the only reasonable person, and they're clearly not reasonable and not honest. Because you can't be honest and reasonable and claim that this doesn't happen, that the lever won't balance. It will balance with 8 times the kinetic energy on one side than on the other side, 4 times. And that can't be true. Can't have 4 times the energy and be an oscillator. Oscillators can't have 4 times the energy on one side of the oscillation. Can't happen.
Of the other if energy is supposed to be conserved.
I mean, this really forces a critical question, doesn't it? If kinetic energy is the real deal, does that mean a simple lever is just creating energy out of thin air?
Right, exactly. So by their theory, that's what they're claiming. And clearly it isn't, because momentum is the only thing actually conserved, and it's the only thing that actually ever does work.
It seems to violate one of the most basic laws of physics. The momentum model, though, it shows a perfectly balanced system. No magic, no paradox.
And the source points out that this isn't just some weird quirk with levers.
So it's good we got the different examples. The rocket ship thrust, if you calculate the kinetic energy, it won't have anything to do with what the rocket gets. So he'll say 10 billion joules. Will the rocket leave with 10 billion joules of energy? No, it'll be 1 billion. So in every circumstance, the gun, the bullet, 1,000 times more energy flying off with the bullet, 1,000 times less recoil of the gun. It makes no sense. Same explosion produced both events. One part of the explosion goes left, one part goes right. They're claiming that because the gun is heavy, it has more inertia. Well, they claim that the light things going fast have more inertia. So how is the bullet going so fast? Because they claim going fast requires more energy. So it doesn't make any sense. All contradictions. Now this, I don't have any idea what this is. I guess it's a pendulum, maybe? Don't really know what the hell that is. But obviously car crash right there. Mythbusters kind of did this. Been there, done that. You crash the car at twice the velocity. It does not crush 4 times as much, proving there's not 4 times the energy in the car.
Think about it. When engineers calculate the thrust of a rocket, what do they use? They use the momentum of the exhaust. When accident investigators analyze a car crash, they use momentum. And what about a gun? A bullet might have thousands of times more kinetic energy than the gun's recoil, but guess what? Their momentums are perfectly equal and opposite. In all these real-world examples, it's momentum that's conserved and predictable. Kinetic energy, it seems to just vanish or appear out of nowhere.
Next up, Section 4. The photon is an event. So this model doesn't just stop at motion. It also offers a really different way to think about light. And it tries to get rid of that whole confusing, is it a wave or...
Yeah, well, it doesn't try. It just does. As a consequence of getting the right answer, you get rid of all this crap. But this again, this drawing's a little bit, who the hell knows what this is doing. 4-bit model, they have stuff written and then they put the stuff over the stuff they wrote. So it is a little bit all art and no value for this slide, I would say.
Is it a particle thing?
Right, so here's the core idea. A photon isn't a thing you can catch. It's an event. It's the process that happens when a whole bunch of these tiny force bits hit a surface in a very specific sequence.
Right, and so again, this is a nice graphic, but it's not anything to do with my argument. It's destroyed the nice straight line vectors, the consistency of the objects, the sameness of them, and they've turned it all still into this kind of a wooey portrait. So the AI still can't even, it can't find a reference, I guess, that that has. I guess if I talked more about lenses, okay, and the geometry of the math, maybe that would have got it. Maybe I have to put another, another video on the 2-slit or something to get the idea that this stuff has to be straight lines.
At just the right time.
And there's a great way to picture this. Think about trying to tip over a big wobbly pole. If a single force bit hits an electron, it just makes it wobble a bit. No big deal. Now, if a second force bit comes in and hits it at the wrong time, like when the electron is moving back towards it, it just cancels out the energy. Nothing happens. But if that second bit arrives at the perfect time, right when the electron is at the peak of its wobble,
So it wouldn't be necessarily the peak of its wobble. The peak of its velocity would be even better. But anyway, continuing.
You add to the energy, and bam, you can kick that electron right out of the atom. That perfect timing, that's what we call frequency. All right.
All right, so that's obviously not what you call frequency, but it's why high frequency light is more effective at moving electrons than low frequency light, is because it doesn't waste as much energy, because it conserves the energy by decreasing the time that the electron has to be dragged to have its energy absorbed by friction. It reduces the time friction has to absorb its energy. I guess would be a more precise way to say it.
Section 5, matter shapes the force field. So we've seen how the model says force moves matter, but it's a two-way street. Now we're going to look at how matter itself interacts with all those force bits to create the big forces we experience every day, like gravity and pressure.
And a really simple way to think about this is that energy is all about density. The more force bits you can pack into a small space, the more pressure you have, and the more useful that energy becomes.
So that's sort of the catch is, yeah, I mean, it's hotter. Use is always a tricky word. But anyway, I guess this is an okay argument. So this is sort of what happens when you slow the force down, you thicken it, okay? And that's what happens when, like, inside the Earth, is there's a lot of thickening of the force.
Imagine you have 6 beans in a giant jar. That's kind of low pressure, not much going on. But what if you take those same 6 beans and cram them into a tiny little jar? Now you've got high pressure, high energy.
Yeah, well, that was sort of an exaggeration, wasn't it? yeah, they didn't. Sometimes these jump cuts, they jump a little too quick. The sentences aren't complete, But, those are little imperfections. I'm sure they'll work that out. Because, yeah, sometimes they just don't quite finish a word before they start their next sentence. And I don't know what the hell this could be. But anyway, I guess it's supposed to be gravity. But, yeah, it's not a very good illustration.
Okay, so this leads to a pretty wild idea about gravity. The model says gravity isn't a pulling force at all. It's a pushing force. Picture the whole universe just filled with these force bits flying around in every direction. Now, when they pass through something big and dense, like the Earth, a lot of them get absorbed or reflected. They get clogged up. This creates a kind of pressure shadow around the Earth. So you, sitting in your chair, aren't being pulled down by the Earth. You're being pushed down into that low-pressure shadow by all the force bits hitting you from every other direction in the universe. It's not a pull, it's a push.
So, an unsettled science. After looking at this whole 300-year-old idea, what are we supposed to make of all this?
Well, what we've walked through here is a model that claims...
Ew, pink. Ew. Anyway, let's see what they have here. Momentum, kinetic energy, force bit model. I don't know what that is. Yeah, it's kind of weird.
Momentum, MV, is the real conserved energy. It's consistent with levers, collisions, rockets. It's simple and mechanical. On the other hand, it says kinetic energy, 1/2 mv squared, creates these weird paradoxes in simple machines and is constantly getting lost as heat. This force...
So it doesn't get lost as heat. That's just a claim. It's never collected. So therefore, it's never tested, and it's just a fable.
Spit model claims it can unify everything, motion, light, and gravity, with just one particle and one simple mechanism.
And the source material doesn't pull any punches. It basically concludes that the whole kinetic energy story is, well...
So this is pretty good. Yeah, this is sort of like a Goldilocks with her porridge. And she's running from the wolf that's wearing Red Riding Hood's thing. So she, I guess, got eaten already. So it is kind of funny. I mean, it's a very clever little piece of art. I don't know if you see that. Yeah, you can see that. And 300 year, they have little pits in here, so it's funny. Anyway, continuing.
Well, just that, a story. It calls it a fairy tale, like Goldilocks or Little Red Riding Hood, something that's been told for 300 years, but is, in its view, completely baseless.
And ultimately, that leaves us with this question. Science is supposed to be all about challenging old ideas, right? So, does this 300-year-old formula, one of the bedrocks...
So they got one old brown guy, and three teenage girls. Hilarious. That's profiling science.
To physics deserve a fresh look? It really makes you wonder, what other fundamental ideas do we all just accept without question?
So they use gears a lot. So, obviously that's a pretty substantial thing in this history of science is gears. All right, so what I will do here, let's see. I'm thinking maybe I'm going to use this video as a source, put it back into the, as a feedback loop and see what it regenerates with my corrections. It might be interesting to see what it can produce out of that. All right, so maybe I'll play one of the audio files and just put something else up here as a video freaking thing. Well, I guess I could just get rid of the drawing. Well, if I'm doing audio, I could draw, I guess, while the audio is playing. Yeah, maybe we can do that. Yeah, something like that anyway, and such. Yeah, I can make this bigger. Okay, that might be acceptable. And yeah, so I'll play one of the audio files. Let's see, momentum versus, so this was a debate format, okay, and so you can only get audio for debates. So we'll play that.
Welcome to the debate. Today we're diving into a conflict
Alright,
that
so this
is,
a
well,
really
less
crappy
about.
voice,
Welcome
in
to
my
the
opinion.
debate.
Okay, really crappy. Don't like it at all. So I have to load this again. And all right, I think that's it. Nope, that ain't it. That should be it. Okay.
Welcome to the debate. Today we're diving into a conflict that is, well, less about modern physics and more about the historical foundation of classical mechanics itself. It's a foundational disagreement that has persisted since the 17th century
I
and is
guess you
being
don't
rigorously
need this
challenged
because-
once again in the source material.
Right. We're talking about
don't need
motion
that.
and really how we quantify the energy inside that motion.
Exactly. The central question is fundamental. Is the true conserved energy of motion represented by kinetic energy defined by the mass times velocity squared relationship, 1/2 mv squared? Or is the sole, fundamental, universally conserved quantity simply momentum, mv? I maintain that the capacity for work and the reality of energy conversion necessitate that quadratic relationship of 1/2 mv squared.
And I believe that the entire 1f squared formulation is an axiom, one inherited through history that introduces just unnecessary complexity and profound paradoxes. I assert that momentum mv is the only true measure of force and energy, as it's the only quantity that is consistently and perfectly conserved through every physical interaction.
Okay, so to understand why the 1/2 mv squared framework is, in my view, indispensable, we have to ground ourselves in the definition of work. Work is force applied over a distance. The dependence of kinetic energy on the square of velocity is physically necessary because of how distance relates to sustained force. If you apply a constant force to an object, its velocity increases linearly with time, yes, but the distance it covers quadratically with time. So the object's capacity to do work, to crush something, to lift something, to generate heat, is proportional to the square of its velocity.
Right, but there's just no proof, so it's a statement. There's no proof behind it. And things, again, it requires you to believe that things with different momentums can do exactly the same work. And it just doesn't make any sense that things with different momentums can do exactly the same work.
This isn't just a mathematical curiosity. It's the framework that lets us quantify.
See, this voice, she doesn't sound like somebody who's ever done any physics.
Energy migrating into other forms. Think of a car crash. Doubling the speed increases the destructive energy 4 times over, which is exactly what the v-squared term predicts.
See, your flaming of kinetic energy.
Yeah, it's you saying so doesn't mean it's so. So she just said something the Mythbusters absolutely proved, completely suspect, we could say, because they got exactly the opposite results. I mean, decisively the opposite results. And that's it, should be able to change the voices using it. Yeah, well, not using, I'm just saying you can't do it with this Google program, whatever it's called, Notebook LM thing. You just can't yet. Maybe someday they'll let you do that, but you can't do it currently. You have to put it all into another program. So somehow you have to put in a video and then get the transcript and then take the transcript to another place and so it's kind of a pain in the ass. I mean, I might do that eventually sometime, but I have to do this one step at a time. I have to learn how to do this first before I can start doing other stuff.
As a measure of work over distance is precisely where the logical flaw begins. You're defining the result based on a prerequisite definition of force, not discovering a truly fundamental conserved substance. I propose a mechanical elemental model. Energy, or force, is a substance made of discrete quantas of momentum. In this push universe model, mv is the only thing transferred and conserved. Where conventional physics goes wrong is defining gravity and potential energy as distance dependent, as mgh. If we just stick to fundamental Newtonian mechanics, force causes an acceleration that is time dependent. Velocity increases linearly, 9.8 meters per second of exposure to the force. So the force delivered should be proportional to mass times acceleration times the time interval. This elemental reality,
obviously it should be times time, but we guys see he's just doing this per second thing again. There's no per second, obviously. It's nonsense.
Makes the whole quadratic dependence on velocity, the v-squared term, completely unnecessary and frankly misleading.
I see the appeal of simplifying it all down to time-dependent linear momentum, but your model struggles to account for energy conversion and the empirical reality of things like fuel costs.
So again, she's claiming there's some sort of evidence. There's no evidence. So again, it's just bullshit.
Proponents of the MB model often lean on one of the oldest mechanical proofs we have, the law of the lever.
Yeah, right. There you go. Bingo. You lose.
And rightly so.
Yeah, you lose, bitch. You're done.
The law of the lever is definitive experimental evidence.
Yeah, it's over. Again, there's no reasonable interpretation. So if we all, I'm just saying, if they do the experiment and they find that the law of the lever is somehow levers don't conserve momentum, which won't be the result, right? If they do the experiment, they're going to find they conserve momentum because they've been conserving momentum for thousands of years. That's what they do. So it's just a fact. It's not going to do the 1.4 thing. All right, it's not going to show that it takes 4 times the energy to go twice as fast. None of that's going to be shown.
It's validating MV. Look, take a classic balance. If you have a 1 unit mass moving at 4 velocity, and you balance it against a 4 unit mass moving at 1 velocity, the momentum, MV, is equal on both sides. 4 equals 4. The lever balances.
And it shows you, I mean, it sits there and oscillates, showing you that, yes, a 1 mass going 4 velocity is the same as a 4 mass going 1 velocity. And it shows you that it's the same because it just keeps doing this over and over and over and over and over, demonstrating that there's no way it could lose all the energy and then get it back and then lose it and then get it back. Can't do any of that. So it just proves it, decisively proves it.
This shows an equality of force, or energy. Now, if we accept the 1/2 mv squared formula, the object with 4v should have, what, 8 units of energy, while the 4m object has just 2 units.
So I'm just saying, you know that if you just let the objects fly off, right, if they could fly off the lever, right, you're still going to just have a 1 mass going 4 velocity and a 4 mass going 1 velocity. That's what the lever is going to produce. And the same motion will produce those actions. So there's just no way to say there could possibly be 4 times the energy on one side of the lever. It can't be.
You're claiming a massive difference in energy, a 4-to-1 ratio. Yet the lever, this simple machine, detects them as perfectly equal. It's a solid, mechanical system contradicting your fundamental measure of energy.
Yes, you dumb bitch.
Well, the issue with the lever example is that you're confusing static equilibrium with total energy.
There's no static equilibrium. We're not talking about static equilibrium. We're talking about an oscillator that can go, basically, it'll go static equilibrium, but we're talking about the fact that it oscillates evenly on both sides. Same motion on both sides. The lever moves exactly the same on both sides.
Transformation. The lever is designed to conserve angular momentum.
No, it's designed to conserve, period, and it conserves momentum. Frankly, there isn't anything called angular momentum. There's just momentum.
Through mechanical advantage.
You can't say that the Earth orbiting the Sun has angular momentum. It just has momentum. It's just moving a velocity, period.
It doesn't measure the total capacity for work.
Yeah, it does.
We agree that momentum is conserved. That's Newton's third law.
Right, and you can't conserve both. So there are calculations when you're changing a mass, and in the case of the lever, we're changing the mass. We're putting a 1 mass versus a 4 mass. So we're obviously dramatically changing the velocity in the squared component. So therefore, the two numbers can't match. What appears to be exactly the same momentum will not be the same kinetic energy.
However, the lever can't detect the energetic difference because it converts that difference into internal losses.
Says you. So again, there won't be any place where any of these internal losses will be demonstrated to exist. It runs out of energy very slowly.
A proponent of v squared would argue that if you were to suddenly stop that 4v mass with a brake, it would generate 4 times the heat compared.
Okay, so there's no point in saying that because it won't. It'll just go, it's going to be doing exactly what it was doing when it was being pushed by the lever. It's going to move 4 times the velocity, and it's not going to generate any heat, and it's not going to do any of these crappy things you say it's going to do. It's all made up, and you can't prove any of it. And the simple argument is the same motion on the other side of the lever is not going to create that same amount of energy. And you have to explain why it didn't. How can one side of the lever make 4 times the energy the other side is making when it moved exactly the same?
To the 1v mass. The lever is just a passive mechanical conduit.
Now exactly. It can't make more and it can't take more. It can't steal any energy and it can't make any energy. It's one side's moving exactly the same as the other side. Same thing, same movement. The same action by the lever can't make different amounts of energy.
Any excess energy from that v squared term would be dissipated internally as friction, heat, internal stresses in the fulcrum, which the lever is not equipped to quantify.
But that's precisely the problem. You're suggesting that this vast energetic difference is somehow hidden and vanishes into friction, yet it fails to show itself in the external function of the machine. Let's make this clear.
Yeah, you're a dumb bitch. No, sorry. I'm taking advantage. Yeah, Jane, you ignorant slut. I'll grow up eventually, and figure out that, yes, okay, eventually, women will, be real. They won't be posing, and they'll be like real scientists.
If I replace the balance arm with 2 perfectly elastic plates and let those masses hit them, the resulting recoil will still be equal because the momentum is equal. The v squared term, the extra energy you claim is 4 times greater, does nothing to change the momentum transfer. If that energy is real, it has to manifest clearly in the external world.
And it does. It manifests.
So it doesn't. So that's the big fake, phony, fraud bullshit.
In the work done against external forces.
Right, and there's no evidence of these experiments where it does any of this extra work, especially in cases like rockets, where the thrust can't even move the spaceship.
Even if the linear momentum transfer is balanced. So if we acknowledge that static systems like the lever are insufficient, we have to turn to dynamic, highly inelastic.
All right, so obviously the levers are dynamic, so it would be just idiotic not to concede that levers are dynamic. Something sitting and oscillating 100 times in front of you is dynamic.
Interactions to really see where energy is dissipated. This brings us to the most powerful demonstration of the quadratic relationship.
Yes, the one that proves it even more. So again, it's just so funny that she's making these arguments that somehow these experiments indicate some survival theory for kinetic energy when these are decisive experiments illustrating the flaws of kinetic energy. So she's going to bring up the ballistic pendulum of all things.
The high-speed collision, specifically the ballistic pendulum.
Ah, yes. This is where 1/2 mv squared reveals itself to be a concept of phantom energy.
Yes, it's that simple.
When a high-speed projectile hits a heavy stationary pendulum, the results are very revealing. Momentum is nearly perfectly conserved. The linear momentum of the combined mass, the bullet plus pendulum, accounts for maybe 98-99% of the initial MV.
Mm-hmm.
Right, and where's the 2% you lost? Oh, that's the heat. That's the 2%. You're missing 2%. 2% is lost to heat. You move the clay around a little bit. You move the gel around a little bit. So it costs you a little bit of energy, but it's a tiny amount of energy.
However, when we analyze the kinetic energy, we find that a minuscule fraction, less than 1%, is converted into the pendulum's motion, while the vast majority of the initial kinetic energy, often over 99%, is immediately converted into heat and localized deformation.
So they say, right? So the deformation is never permanent. So it can only be one or the other. You can't say deformation and heat, because the deformation is what you use to create the heat. So they're the same thing. They can't be, it deformed and it made heat. It's always it made heat through deformation. So deformation is the road to making heat. It's not a separate thing. You can never use the energy. You can only transfer it. So there's no such thing as using the heat by deforming. Deforming always converts the heat, converts the energy, the motion, into heat. So they don't even say those kind of things scientifically.
This massive loss proves that kinetic energy is a real capacity for work that gets instantaneously consumed by the internal forces of the collision.
But wait a minute. That doesn't
instantaneously. So that's like one of the first times they made a mistake saying something, you know, almost. And it is funny that it's this woman's voice that isn't a great woman's voice either. So it is funny that that woman's voice that I don't think is very good at, you know, making the point. So the energy goes in 99.94% lost. KE. Okay, 98% conserved MV. Yeah. Completely different outcomes, right? So most of the momentum's conserved. Obviously, you can't make a whole bunch of heat, all right, and conserve 98% of the momentum. Can't be done. You can't make heat and conserve your momentum as linear motion. You can't do both. Can't knock the bowling pins down and keep your momentum in the ball, right? But that's what they're trying to argue. They're trying to tell you that the ball still has all of its momentum as linear motion, and it knocked down a whole bunch of pins. Now, any reasonable person, reasonably scientifically literate person, would have to concede, no, you can't say that. You can't say, I'm going to keep all of my 98% of my bowling ball's momentum, and I'm going to knock down a whole bunch of pins. You know it. You know you can't say that. You know that can't happen anywhere in this universe. So why are you arguing with me? Why? Because you hate my guts. Oh, that's it? You don't have anything better than that? Ugh, fuck. Yeah, oh yeah, you people are just... you're such fucking human garbage.
Track logically if energy is elemental momentum. Let's unpack that claim about heat. If MV is almost
Okay, so this is the big giveaway when you're watching, listening to some of this crap, and they say this unpack term, because that's all this AI always does. It always throws unpack in there somewhere, so it's always a giveaway. As soon as you hear the word unpack, you should be saying, "Oh, AI." They ought to just let that one go.
perfectly conserved, yet thousands of units of heat energy are generated, you're asserting that this immense thermal agitation, which in my model is composed of elemental momentum quanta vibrating rapidly, required almost none of the initial bullet's momentum to create. You're effectively claiming the system managed to conserve 99% of its original linear momentum and simultaneously generate massive amounts of new, chaotic momentum in the form of heat.
There's my argument. He just made it perfectly, right? So he made it better than me, said it better than me. Okay. But yeah, he just said what I just said. You know, how can you have released thousands of joules of heat and you kept all of your linear motion? You can't do that.
I mean, that's the very definition of creating free momentum in a closed system.
That's free energy in a closed system,
which is a conceptual impossibility.
You're mischaracterizing the nature of energy conversion versus momentum conservation. Momentum is a vector quantity. It has to be...
Oh, yeah, she's going to do this vector scalar crap. Let's see how it handles that. I don't remember what it says here.
...conserved in its direction. Kinetic energy is a scalar quantity. It represents total energy irrespective of direction. When the collision happens, the v-squared energy isn't destroyed. It's converted from macroscopic, ordered motion.
So we already pointed it out. It's the only place it can be is heat. So she already conceded. It has to be heat. So all they got to do is stick up a thermometer in the ballistic pendulum and prove there's thousands of joules of heat in there.
And into microscopic, disordered motion, heat.
So more, yes, exactly. That's your argument. But we've already established, how can you do both? How can you knock down the pins, that is, make the heat, and keep your momentum? I mean, I can't make a heating system that does that, right? I can't make a heating system that creates friction and makes heat, let's say, and the thing that's making the friction just keeps going the same speed. I can't do that, right? I always have to pay for the heat. I can't get free heat. So the heat comes out of momentum. So you can't get it for free.
Heat. The resulting heat doesn't contribute significantly to the linear momentum of the pendulum because the microscopic movement is chaotic and cancels out vector.
So it doesn't even make sense that it would contribute. It can't contribute. It can only take.
Really. The critical point is, if energy were only mv, the total change in linear momentum simply wouldn't account for the massive amount of energy converted into heat.
Right, so she keeps saying there's a massive amount of energy converted to heat. There's no evidence that there's any. And if there was a massive amount, again, then you have to make an argument somehow you don't have to use momentum to make heat. That somehow you can have a free heat engine. No momentum required.
The heat that we observe demands a quadratic relationship to explain the sheer magnitude of the transformation.
All right, so it's just a lie. Oh, it's just terrible that she would do that lying thing. But again, that's the claim, right? They just claim it. There's no physical evidence of this heat thing ever being created by, the 10-ton, 5-ton train. I haven't drawn that in so long. We might as well draw that once. Because it's the same argument as the ballistic pendulum. It's just in a simpler form. So you got a 5-mass train going 10V. You add, okay? You just simply add another 5 to it. Okay, and what you end up with is a 10-ton train going 5 velocity. So you conserve the momentum entirely, but you lost 1/2 the kinetic energy. And their argument is half the KE, okay, is lost to heat or deformation, as they stated. And obviously, how can it do both? How can I conserve 100% in this case of the momentum, the linear motion? I've kept 100% of the linear motion. I have lost nothing. No perceivable energy at all has been lost. And yet, I create half the energy worth of heat. I can't do both. Can't make free heat.
Okay, but this leads to a deeper, more profound problem with your v-squared model. The concept of stored energy. If energy is fundamentally 1/2 mv squared, how do you explain potential energy? Where is the velocity when a spring is compressed or when a ball sits motionless at the top of a parabolic arc? Your definition suggests the energy has just vanished. Yet we know it converts perfectly back into motion when the ball falls or the spring releases. If energy...
We know it only, okay, is again twice the velocity goes 4 times the distance. So it's, and twice the velocity is not going to take 4 times the work to create. So it's just stupid. Half the mass will go twice the velocity. It does happen. It's not a problem.
Energy requires velocity squared. Then stored energy must be a conceptual fabrication.
That is a crucial challenge. And the conventional answer is that the v-squared term quantifies the potential capacity for work to be done. The potential energy stored in a gravitational field, mgh, is energy that has been converted from kinetic energy, work done to lift the object, and stored against the conservative force. When the object falls, that potential energy is perfectly converted back into...
So I hate these arguments about potential energy that only have to do with being in a circumstance that will create the ability for you to find a stream of energy. So, it's the river and the boat. It'd be kind of stupid to say the boat has potential energy because it's sitting on the side of the river. It's not until you put it in the river, that it has anything at all. And it takes from the river. It doesn't get anything for free. The river is slowed down by giving energy to the boat. It's just a fact. It is.
Kinetic energy, following the quadratic relationship as velocity increases. Your model that force is only time dependent, MGT, struggles profoundly here.
No, it
How does a
doesn't.
baseball sitting
Fake. No struggle at all.
motionless at height h possess momentum if it has 0 velocity? Your theory requires stored energy to literally be stored momentum, which
It doesn't matter whether you call it stored anything, stored kinetic energy, stored momentum, it doesn't matter. The point is it's not stored in the gravity. The gravity is an active force. You have to prevent something from flowing. I can hold something in a stream and keep it from moving, and I have to apply a pressure to do that. It's the same thing as gravity. There's no difference. Wind, paint, doesn't matter what I spray, and that's all there are. There are all constant forces are essentially spraying forces. The sun is spraying photons at us.
contradicts its 0 velocity
It's in units of time you get sunburn. You don't get sunburn in units of distance.
state.
I'm not convinced by that line of reasoning because
You shouldn't say that. You should say, shut up, bitch. Your argument sucks.
it still relies on treating MGH as fundamental.
Yeah, and it's garbage. It's nonsense. It's completely a one-trick pony. It only works when you're talking about dropping something a distance in gravity. It doesn't work in any other context. If something already has a motion, you won't get the right answer to the question, how much speed did it gain? You only get the right answer if you understand that it's about how long you're in gravity, not how much distance you move around in gravity. I can go outside and I can walk around in circles, I can run distances, I can go run fast, I can stand still. It doesn't matter what I do. I'm going to get the same amount of sun based on how long I'm in the sun. Distance won't matter.
If energy is fundamentally elemental bits of momentum, then potential energy is simply a state of constrained elemental pressure. When the ball is lifted against gravity, we're using work to hold it against the constant, time-dependent flow of this elemental force. The energy isn't stored in the ball. The ball is merely held in a state of high disequilibrium relative to the constant time flow of the pushing force. When you release it, the elemental force acts upon it again, linearly increasing its velocity over time, restoring its momentum. We don't need a fictitious v-squared term to justify the height. We only need to account for the total time the object was exposed to the force.
Let's pivot to a scenario where the consequences of energy input are critical, yet the resulting linear action is purely conserved by mv, the vacuum thrust debate. If 1/2 mv squared is the true measure of energy, then why does it seem entirely useless in the most elemental environment, empty space?
This is perhaps the clearest empirical nail in the coffin for the v-squared metric. Imagine a spaceship in a vacuum. If I jettison 1 unit of mass at 1,000 miles per hour out one side and simultaneously jettison 1,000 units of mass at 1 mile per hour out the other, since the momentum, mv, is equal on both sides, 1 times 1,000 equals 1,000 times 1, the resulting thrust dictates that the ship should experience no net rotation or acceleration.
Agreed. Newton's third law demands that the recoil momentum balances and the ship stays stationary.
Yet your 1/2 mv squared formulation claims the action of throwing the small mass at 1,000 miles per hour required 500 times more energy input than throwing the large mass at 1 mile per hour. If kinetic energy quantifies the true fundamental energy capacity, why does this massive energy differential fail entirely to influence the resulting motion of the ship?
It's just how can you argue? What's the counter argument that says, okay, yes, that makes perfectly good sense? It doesn't make any sense at all. Obviously, if it isn't obeying Newton's third law, it's not energy. And it doesn't obey Newton's third law.
mv dictates the thrust outcome perfectly, rendering the v-squared energy input measure irrelevant to the mechanical result.
I think you're overlooking the core purpose of 1/2 mv squared.
Oh, yeah. Which is what? I mean, it can't have anything to do with science, right? So it has to do with some kind of, I don't know, some kind of dildo and anuses or something. I mean, what is this about exactly? Why does this crap exist? It's just crap. It doesn't have anything to do with being logical and reasonable. So what's it for? What is this? What weird itch does this fucking idiotic formula scratch?
In this context, it quantifies the cost of achieving that state of motion. That differential, that 500-fold energy cost, is not irrelevant. It represents the actual required energy expenditure.
Again, so it wasn't actual. So you can't say that the explosion somehow gave 500 times the energy to one object than it gave to the other object. You can't make that argument. How's the nuclear bomb going to do that? The nuclear bomb knows how to do that? The nuclear bomb will give, like I put a big giant cliff on one side of the nuclear bomb, that somehow the nuclear bomb is going to know that if I give it but little light styrofoam to push this way, it's going to make 1,000 times more energy than if I make it push dirt or sand in the other side. I mean, it's just a bullshit argument that pushing light things somehow makes more energy. It's stupid. It's silly.
From the rocket's fuel system, it takes profoundly more fuel. And
so, big lie. No evidence whatsoever. Same gunpowder. I put 2 bullets, 2 light things in the gun. One goes this way, one goes that way, right? I mean, I've already illustrated this a million times too, but what the hell? So I can do this experiment, and the truth will be known. All right, guys, same explosion. All right, so, and all I do is change the size of the bullets, right? So that's all. Okay. So I'm going to do the same experiment. 2 bullets. These bullets are going to be 1-ounce bullets, and these bullets will be 10-pound bullets. And the fact is I'm going to get this. It's going to be the same amount of momentum, but your kinetic energy theory is going to say the things moving faster have more energy, but they're going to be the same momentum. So it's just bullshit. You're just claiming they're going to be more energy. There won't be any more. Same momentum.
And thus more required energy input to accelerate a small mass to extreme velocity than it does to accelerate a large mass.
So obviously it doesn't make any sense, right? The gun proves that it doesn't take more energy to move a small mass at a high velocity. The gun proves it. The gun's having a hard time moving the gun. It's not having a hard time moving the bullet. I mean, it's such an overt contradiction. It's exactly the opposite of what they're saying is true.
Mass to slow velocity, even when the resultant recoil momentum is identical.
You are separating energy input from conserved energy, which is logically inconsistent if 1/2 mv squared claims to be the measure of the conserved energy of the motion state. If the kinetic energy is 500 times greater, that energy has to go somewhere that affects the outcome, not just the fuel tank. If I throw both masses at two separate identical targets, the high velocity mass will inflict vastly more damage. It will do more work than the
No, it won't technically do more work. So that's just wrong for him to say that. It won't do more work. It won't move more matter. You can only knock down the same amount of pins. But the fact is, depending on how I stack the pins and how I allow the energy to interact with the pins, yes, faster things can have advantages. Pointy arrows go deeper. It doesn't mean that pointing an arrow means the arrow has more energy.
low heavy mass. This destructive capacity must be inherent in the motion state itself.
Its inherent advantage to moving fast breaks things. Systems are held together by energy that needs time to hold it together. If you break it quickly, it can't react. It can't hold its pieces together. It's that simple. Speed is an advantage. It's not more energy. It's more effective at breaking things.
And that destructive capacity is inherent in the motion state, quantified by v squared.
So, and it isn't quantified by it. It isn't universal. Going 40 miles an hour versus 20 miles an hour isn't going to allow you to break any systems. What you need is a huge differential, like the bullet and the recoiling gun. You need a gigantic difference in the speed to gain any advantage to the speed. But small advantages won't make any difference at all.
The reason the slow, heavy mass doesn't do as much damage upon impact is precisely because it carries less kinetic energy.
So, just nonsense. There's no such thing.
Even though it carries the same momentum, the 1/2 mv squared formulation dictates that the engine must perform 500 times more work.
So we know that doesn't happen. Again, so there's zero evidence that any engine does more work that ever happens. You ever have to use 25 times the fuel to go 5 times as fast? No evidence. It's the evidence actually is the opposite, that it takes less than 5 times the fuel to go 5 times as fast. It takes less.
To achieve the high velocity state, the fuel burned is the physical manifestation of the v squared energy input required. mv dictates the conserved recoil. 1/2 mv squared dictates the conserved energy budget required to generate that recoil. Both are required for a complete accounting.
But you're simply restating the axiom. If we accept the elemental push
Right. You're just restating what we have no evidence to be true. So you just claim there's evidence. They keep saying there's evidence. They keep saying they proved it, and they haven't done any such thing. And like they keep saying they redid the Eddington experiment. They never did. Outside the margins of error. It just hasn't happened. So they just keep claiming it's been done, claiming they have great evidence, claiming the videotape is right over there and you just watch it. There's no videotape. You can't just watch it.
model, the difference in input must relate to efficiency and the compounding forces applied over time. The conventional formula forces us to believe that the system requires an absurd, quadratically increasing energy input, rather than seeing that the difficulty lies in the reduced interaction time when accelerating something quickly.
And again, the bullet and the gun is just so obvious. Obviously, there's no difficulty moving the bullet quickly. It goes quickly really easily. It conserves the momentum really easily, goes up to speed, goes twice to 10, 14. It just goes faster, faster, faster. No problem. No evidence of this inertia problem.
The simpler, momentum-based calculation requires no such arbitrary, quadratically increasing expense.
We seem to have reached the bedrock of our disagreement. The distinction between these two measures is fundamental. Momentum, mv, is the vector state of motion and its strict conservation in linear and angular interactions.
I agree that in any isolated system, momentum must be preserved.
All right, so there's no point in saying you agree, because in all these isolated systems where you change the mass, you cannot conserve both momentum and kinetic energy. So in levers, pulleys, anything where you're doing mass conversions, that is converting energy from a heavy mass to a light mass or from a light mass to a heavy mass, you cannot conserve both. Not physically possible.
And it is the most robust and elegant measure of force.
But 1/2 mv squared effectively quantifies the total energy required to achieve that state of motion, and, critically, the capacity of that motion to transform into non-translational, non-vectorial forms.
Like what? So again, where are these non-vectorial forms of energy? Where are they? Show me a scalar energy ever to exist. Show me one. Somewhere. Show me this scalar energy thing.
The massive amount of heat generated in high-speed inelastic collisions.
So no evidence of any massive amount of heat generated. So again, lie some more.
The deformation observed, the substantial increase in required fuel for higher velocities.
So no increase in fuel, so more lies.
These are all phenomena that demand a quadratic relationship to accurately describe the total.
And they don't, none of those things happen. So again, it's just amazing that, the AI is driving this argument, and it clearly can't produce any evidence for any of that crap.
Energy budget and its ultimate fate.
And I maintain that the simplest, most mechanically satisfying explanation is that energy is fundamentally momentum. The failure of 1/2 mv squared to consistently predict outcomes in simple, balanced systems like the lever, its theoretical paradox in creating free momentum during inelastic collisions, and its inability to define stored potential energy without recourse to an arbitrary mathematical definition, well...
Yeah, some pretty good arguments. Good job. Thank you. Whatever. What's his name? Broderick? Yeah. Rudiger.
It proves it's an unfounded historical artifact. It introduces paradox where Newton's original momentum physics provided clarity.
The tension between the vector conservation of mv and the scalar
there's no scalar.
energy quantification of 1/2 mv squared highlights the necessary complexity involved in accurately describing physical interactions,
Yeah, just jargon and lies.
especially when energy transitions from ordered motion to chaotic heat or stored
So we know nothing's truly chaotic.
potential. The persistence of this centuries-old debate shows that experts must constantly revisit.
Yeah, the persistence of the fact that the evidence doesn't exist and that the science doesn't produce it, that they don't have any interest in answering these fundamental questions decisively. That's the amazing part. Have you traded emails with Dave at all? Yeah, well, I did. And, it was a waste of time. He said he'll, for $5,000, he'll debunk my argument. He'll play one of my videos. And I wasn't willing to pay him $5,000. It's a little over, because he really wasn't that famous back then either. So yeah, fuck him. Yeah, but yeah, it'd be great. Now, if I could get him to do it for $1,000, maybe that would be worth it. Frankly.
Visit the underlying experimental assumptions to truly.
You think he'd want to do it just for the sake of science, right? I mean, the whole thing is I guess eventually, right? I have to be like a flat earther. I have to have a club of flat Earth people or something. So maybe if I could get 1,000 views a video, or 2,000 views a video, then maybe these people would have to pay me attention to me, But till then, I'm not going to get their attention because they don't see me as a threat.
Deepen our understanding of energy itself.
Indeed, there remains substantial room for reinterpretation regarding how we define the fundamental building blocks of energy within the mechanics of our universe.
Yeah, so all we're missing is the experiments that should have been done, right? I mean, the very fact that I can just sit there and say they've never dropped 4 pounds 1 foot and 1 pound 4 feet and measured the impact energy, that is, drop them in a joule tank. Drop them into something where you convert all the energy into heat and you can measure it. They've never done the experiment. And that should, to any honest, decent, science-loving person, that should say to them, yeah, that's shenanigans. That sucks. That's not good science. You can't be asserting something for 300 years and you haven't even tried to test it. You haven't even tried to test it. That's disgusting. All right, so maybe I'll call that a video. See if the commenters have anything else. And then I'll feed this video, once the transcript is done, back into the source, and I'll see what it makes of it. Let's see, maybe I can put up a different graphic. All I have here is graphic choices. Let's see, this one I should be able to put a picture up here. And let's see, download. Let's see what this one looks like. I have no idea. Okay, very big. Very big. Very big. Okay, still big. Yeah, that's a really big image. So that's even nice too. The images are really nice quality. So let's see what this is. I can move me out of here. See, I wish this thing worked a little better. Whatever you call this program, right? I forgot the name of the program. It's really good making videos, but yes, it's, you know, OBS, yeah. Let's see, does Dave sharp, no bullshit style? Ew, fuck you. I don't think he's no bullshit style. You of when you were his age. Well, fuck you, Zach. No, he doesn't remind me at all. He's an asshole. Fucking Dave is a jackass. Pontificating douche. And, you know, he's butt ugly, frankly. But his wife, he's got a real trophy wife. And, you know, those things always annoy me. But whatever, that's just, you know, that might be a little bit petty on my part, but it's just, it does annoy me. But yeah, I hate him. I hate Dave. I hate his whole personality, his persona. I hate the whole fucking thing he does. It sucks. He picks on retarded people and makes fun of them. He doesn't counter their arguments. He just buffoons people. You know, it's all trash talk, frankly. So whatever, but whatever. You can, you know, well, whatever. You can like whoever you want. It's not none of my business. I think his physics sucks, and I think his whole attitude is shit. All right, there. I'll just leave that like that. So this was another thing it made as a slide. So it has the lever here, which is good. And, you know, it did okay-ish here with the reflection and absorption thing, a little bit off. But whatever, not terrible. For a dumb synthetic hunk of software, it's not bad. And frankly, I don't think my style's changed all that much. You know, I'm old, but, you know, I don't think the style of my videos is all that different. I was never young on the internet. I mean, I didn't get on the internet till I was 40, right? Something like that. But I was always young at heart, as they say. Yeah, right. All right, so come on. Any last comments? Come on, comments. Nothing? Got nothing to say, you people? Nothing? Useful at all? All right, then. I guess I'll go. All right. So till the next time and such and so forth and whatnot. Blah, 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 and blah.